Now we are discussing a small topic called bias correction. So far we have discussed about exponential weighted average or moving average. The problem with the exponential weighted average or moving average is in the initial stages it is failing to give the real average value. Example we can check. What is the V naught equal to 0? If you are giving the weight 0.98, we already know we can calculate the 50 days average temperature. But first, the equation I am writing, first day average temperature, 0.98 into V naught. What is the 0.98 into V naught? It is 0. So I can remove this term. Plus 0.02 theta 1. So V1 equal to 0.02 theta 1. So I am asking what is the first day average temperature? You are saying 0.02 into first day average temperature. It is itself is a contradiction. If I am asking to if there is only one student in the class, his marks are some 90. Now I am asking what is your average? What is this class average? That class average is 90. If you are telling 0.02 into 90, that is an error. But this is what really happening here. By taking this only, when we progress up to V50, definitely it is giving the right value. But now my question is there any method or approach which can correct me even when I am finding for the first day moving average? Now, there is no doubt when we are progressing up to V50, definitely it may give the correct value. But now I want even in this initial stages also, I am expecting a proper value, means the correct value. Then we have to do the correction, which we are calling as a bias correction. To do this correction, simply whatever the value we are getting in the initial stages, we have to divide it by 1 minus beta power t. This t is the number we are taking. Example, if we are considering for 1 day moving average, we have to divide with 1 minus beta. So if we divide, example, we have calculated, our problem is V1 is equal to 0 plus 0.02 theta 1. Now, according to our concept, we have to divide this V1 with 1 minus beta power transpose, means beta power, sorry, not transpose, beta power t. Now t is 1 because only for 1 day. What is V1 by 1 minus beta? 1 minus beta means 0.98. So we should divide the V1 by 0.02 to get the correct value. If we divide the V1 by 0.02, then this 0.02 will be removed. Then V1 equal to theta 1. That is what we are expecting. The first day moving average temperature should be theta 1 only, right? So this is how we implement Vt by 1 minus beta power t. If t is equal to 2, then we will write 1 minus beta whole square. If t equal to 3, 1 minus beta whole cube. But when it is, we are finding for V50, it is 1 minus beta power 50, means 0.98 power 50 is almost negligible. We can almost neglect it. It is very smaller value. So this is how the bias correction we are taking is affecting only in the initial stages. It is not affecting in the later stages. That is what also we are expecting. Our bias correction should change the should change the values in the initial stages only. So by implementing the bias correction, we are getting the moving averages for the initial stages also in the exact way.